This session is about greedy method. It is how to find minimum cost spanning tree using greedy method. So let's see first what is greedy. What is greedy method? So greedy method or greedy algorithm is an approach for solving a problem by selecting the best option available at the moment. So without worrying about the future result or future outcome the algorithm brings. Uh, we can also say the greedy algorithm uh, finds the best choices aim at producing globally best results. So what are the advantages of greedy algorithm? It is easier to describe and the algorithm can perform better than other algorithms in few cases. So how greedy algorithm works? Always greedy algorithm begin with the solution set. The solution set is at the end of the algorithm. The solution set contains answers or solutions. Initially, the solution set is empty. Then at each step, the item is added to the solution set. So if the solution set is feasible, then the current item, so what we are considering will be added into the solution set. Otherwise, the item will be rejected and it will not be considered again. So there are two algorithms to find the minimum cost spanning tree using greedy approach. One is Kruskal's algorithm, other one is Prim's algorithm. So what is a minimum spanning tree problem? So given a connected, weighted, undirected graph G, so the algorithm outputs a minimum spanning tree of graph G. So how to find the minimum spanning tree? So using Kruskal algorithm and Prim's algorithm. So what are the applications of minimum spanning tree? So minimum spanning tree, minimum cost spanning tree, so mainly used in communication network and laying of communication link between two stations, which involves a cost. And we can also use to construct highways or railroads spanning several cities. Then we can use the concept of minimum spanning tree. We can also use to design local area networks and for laying pipelines which connects offshore drilling sites, refineries and consumer markets. And you can also apply electric power, water, telephone lines and sewage lines for a set of houses. So to reduce cost, you have to connect houses with the minimum cost. So we can use the algorithm of Kruskal and Prim's algorithm to solve this problem. So let's start with the Kruskal's algorithm. Kruskal algorithm, the objective of the algorithm is to find the minimum cost spanning tree. So the set of edges that the T is the solution set, which is going to contain set of edges initially empty. As the algorithm process, edges are added one by one at every instance. The partial graph formed by the nodes of G and the edges in T consist of several connected component, but at the end of the algorithm, only the connected component remains, which contains all the vertices in the given graph. So the final graph does not contains any cycle. So that is the property of spanning tree. So spanning tree contains vertices, all the vertices of a given graph and the edges without forming any cycle. So this is the graph considered for discussion. The graph contains 5 vertices. So vertices are named as 1, 2, 3, 4, 5, and the number on each edge represents the cost. Okay, it can be the cost of traveling from vertex 1 to 2, or the distance between vertex 1 and 2. So we are going to find the minimum cost spanning tree. That is the minimum cost spanning tree. It gives the graph which connects all the vertices with the minimal cost. So how the Kruskal algorithm works? So there are 3 steps involved in it. First is sort all the edges from low weight to high. That means as based on the cost, you sort all the edges in the ascending order. In the ascending order, that is from the low weight to high. Then the second step, take the edge with the lowest weight or lowest cost and add it to the spanning tree. So initially the spanning tree is empty. Select the low edge with the lowest cost, then add it to the spanning tree. And if the addition of the new edges, the addition of new edge forms a cycle or creates a cycle, then reject the edge. Don't add it, because spanning tree, the spanning tree does not contain cycle. That is a property of the spanning tree. So if addition of any new edge forms a cycle, then reject it. Step 3, keep adding edges until we reach all vertices or until the spanning tree contains all the vertices in the given graph. So these are the steps involved in Kruskal's algorithm. So first step is to arrange the edges in the increasing order of their cost or weight. So as per the first step, the given graph edges are sorted in the increasing order of the cost, that is 1 to 2. The edge 1 to 2, the cost is 5. 1 to 3, the cost is 10. 2 to 6, the cost is 20. 3 to 6, the cost is 25. 4 to 5, it is 35. 2 to 4, it is 45. Then 45, 50, 55. So now all the edges are sorted in the increasing order. The next step is, so we have to, if we have to construct the spanning tree. So for to easily for understanding purpose, the table is used. First, the table contains 4 columns. First step, then edge to edge we are going to consider, then the connected component, then the final graph, or that is the minimum cost spanning tree. So initially this set is empty. Initially the edge, what we are going to edge consider is, it is empty, and these are the connected components individually. Now all the vertices are, it is our individual component. At the end of the algorithm, we will get the connected component. There is only one connected components. At the initial stage, all are individual components. Okay, so the graph is empty. Okay, the spanning tree is empty. Now as per the algorithm, first we are going to consider the first edge with the lowest cost, that is 1 to 2. So 1 to 2, so we are adding into the graph. So 1 to 2, since this is the first edge, there is no cycle, so we added. Now the connected components are 1 to 2, it is already added. The remaining, the components, individual components are 3, 4, 5, 6. Then consider the next edge, 1, 2, 3. So add it to the graph spanning tree. So this addition does not create a cycle. So accept the edge into the spanning tree. Then now the connected component would be 1, 2, 3. Then 4, 5, 6 are individual components. Then, so continue the algorithm. So continue the algorithm. Consider the next edge, the 2 to 6. So add it to the graph. 2 to 6, addition of edge 2 to 6 is not forming a cycle. So accept the edge. So now your spanning tree contains 4 vertices, 1, 2, 3, and 6. So now next consider the next edge, 3 to 6. So 3 to 6, add the edge into the spanning tree. So addition of 3 to 6. So addition of 3 to 6, that is here. So we are adding, this forms the cycle. This forms a cycle. So this edge is not accepted because it forms a cycle. So then repeat the algorithm. Consider the next edge, 4 to 5. 4 to 5. So addition of 4 to 5 is not forming a cycle. So accept it. Now we got 2 connected components. One is 1, 2, 3, 6. Other one is 4 to 5. So 4 to 5. Now it is not a single component. It is two connected components. So repeat the algorithm. So the next edge is 2 to 4. 2 to 4. Add 2 to 4 into the graph. So 2 to 4 it's not forming a cycle. So accept. Then consider next edge, 5 to 6. 5 to 6. So addition of 5 to 6, it's forming a cycle. So reject it. Even 4 to 6 also forms a cycle. So reject it. So rejected. So now this spanning tree contains all the vertices in the given graph. So 1, 2, 3, 4, 5, 6. So all the vertices are added into the spanning tree. And now it is an individual component. That is, all the vertices are connected. You can traverse from one vertex to other vertex. So this is the spanning tree. That is a minimal cost spanning tree. So because every time we are choosing the edge with the minimal cost. So the algorithm gives the minimal cost spanning tree. So then 4 to 6, 2 to 5 also, it's not added because it forms the cycle. And this is the algorithm of Kruskal algorithm. So this Kruskal algorithm, it takes three parameters. One is T, that is the solution. So this parameter T, is going to store the final spanning tree. Then E is the set of edges and N is the number of nodes in the given graph. Okay. So initially the solution set is empty. Then, so we have to repeat the algorithm until we process all the until we process all the edges in the given graph. Okay. So this is the algorithmic steps. So T not equal to N minus 1 and E not equal to 0 until we process all the edges and until we add all the vertices in the minimum spanning tree. So we have to repeat the step. So the first step is we have to find the minimum cost edge in T. We have list of edges E. From that, we have to find the minimal cost edge. That call the edges UV. And add the if U comma V does not form a cycle, then add it to the solution set. Initially T is empty, so you can add it T plus U comma V. Otherwise, what you do, delete the edge. Okay. Next, again find the next minimal cost edge. Name the edges U comma V. Then add it to the try to add it to the set T. If it is forming a cycle, add it, otherwise delete it. Then again find the next minimal cost edge. So continue the same step until you process all the edges and until all the vertices until we add all the vertices in the final spanning tree. So there you have to continue. So once if any one of the condition fails, then the algorithm stops. Then finally, if T equal to N minus 1, the T equal to number of vertices, then display the spanning tree. Otherwise, you can display there is no spanning tree. Sometimes graph may not contain spanning tree. So that is also fine. So based on the number of vertices in the graph, you can say the spanning tree or not. The spanning tree must contain all the vertices in the given graph. So if T equal to N minus 1, that is, it starts from 0, so it is N minus 1. So the graph, you can display the spanning tree. Otherwise, you can display no spanning tree. Thank you.